Hello everyone, my name is Mlungisi Nkosi and welcome back to our channel. Today we'll be looking at, we're just continuing on sequences and series, and we are looking at sigma notations. So if you are new to our channel, welcome, and please consider subscribing and just being part of the family. And by the way, we are trying to garner that 50K mark. Trying to work hard towards that. And for those of you who might need assistance or need to get in contact with us, our email address is info@mlungisinkosi.co.za. All right, so let's get into the lesson. All right, so today we're looking at, as I said, sigma notations, and I just want to make this as short as possible. So I'm just quickly going to jump into examples, but just a couple of pointers that I wanted us to make when it comes to sigma notation. So a sigma notation is basically a shorthand notation of a series, okay? So what you need to do, or what you need to know, is that we've got what we call a counter. So the symbol sigma that I've drawn here simply shows you that it says it's the sum of something, right? It's the sum of something. So we've got a counter. Now, sometimes they would say, let's say the counter starts from 1 up until 30 or 1 until n. Now, you consider if the counter shows you the number of terms that you would have in that particular series, right? Now, and then you have the general expression, which is, let's call it Tn here. You would have the general expression, and the general expression would give you the, the terms that are, the terms in the series, okay? So you must just keep in mind, sometimes you would have a counter. Let's say, in this particular case, our counter starts from 1 up until 30. Right, so it means that you'd have term 1 up until term 30. Okay, so how many terms would you have? You would have 30 terms. Obviously, you'd be counting from 1 up until 30. But if, for instance, you've got a counter, let's say it's k is equal to 3 up until n. Okay, so let's say n number of terms, and we've got an expression there, tk. Right, now you would imagine, if we started from 1, you'd be talking about n number of terms. But in this particular case, you are not starting from 1, you're starting from 3, right? So how many terms would be missing? It means that you're missing 1 and 2. So essentially, your term 3 is your term 1. I hope you get that, right? So in this case, we're missing 2 terms. So it means that the total number of terms should be, in this particular case, n minus 2, okay? Because you're missing the first 2 terms, in a sense. Okay, so just keep in mind that that counter is very crucial in order to tell you, how many terms you have in that series. All right, without any further ado, I think let's jump into examples so that I show you how to go about navigating this particular part. Okay. All right, let's start with our first example. So they've given us, there's the sum from k is equals to 1 up until 30, and we've got our general expression right there. So what I'm going to do is just, have to learn to use different color variations just to show you what I'm trying to do. So first of all, let's find out what are the terms that we have. Look at our counter, it's starting from 1 up until 30. Okay, so in this particular case, we know we're starting from 1, we're going up until 30. Okay, so we're going to make sure that we get the first term, so T1. In this case, it means we're going to substitute 1 into that expression there, 8 minus 5k. So there's our expression. So we're going to just make sure that we substitute for 1, and then we're going to increment as we go. So we want term 1. So that's going to be 8 minus 5 multiplied by 1. So that's 8 minus 5 into 1. And what about term 2? That would be 8 minus 5 sorry, 5 times 2. Okay, let me just erase that so that yeah, it doesn't disturb us. Okay, so that's 8 minus 5 times 2, and obviously term 3, that would be 8 minus 5 times 3. Of course, if we started from 2, you'd start substituting 2 there, and 3 and 4, and you'll increment as in that particular order. All right, so 8 minus 5, that would give us 3, so that's our first term. 8 minus 5 times 2, and that's 8 minus 10, that would be minus 2. And the third term, that's 8 minus 5 times 3, that's 8 minus 15, and that would give us a negative 7. All right, so now here's our sequence. So we need to find out first what type of a sequence it is. Okay, so if I look at it, let's take the difference there. So if I look at that, the first difference, 3 minus a negative 2, in fact, no, term 2 minus term 1, so that's negative 2, okay, subtract 3, so that would give me negative 5, agree? So negative 7, once again, term 3 minus term 2, negative 7 minus a negative 2. So you should be careful there. So that would be negative 7 minus a negative 2. So obviously a negative times a negative becomes a positive there. So you end up with minus 7 plus 2, which also give you a negative 5. Okay, so we know that in our sequence, we've got negative 5 as our common difference. So definitely this is an arithmetic sequence. All right, so remember, what is the sigma notation telling us? It's telling us we must get the sum. Okay, so in this case, we know how to get the sum. So it means that we would get the sum up until the 30th term in that case. Okay, so I'm just quickly going to do that. Okay, so it means that we are looking at, remember, in this particular case, it means that we're looking at 30 terms because we started at 1. So what this means is that I'm going to take S30, okay? Remember formula, so we've got S30, which is equal to, in fact, let me just write the formula, as an expression first. Rather the formula just in the general form. Okay, so we've got Sn. Okay, so we've got Sn is equal to n over 2 into, okay, that's 2a plus n minus 1 times d. Okay, so just keep in mind that's our formula for the sum of an arithmetic sequence. We know this is an arithmetic sequence. We've got a common difference. So now we're looking for S30. Okay, perhaps I should make my brackets a little bit different so that it's visually appealing. Okay, so this is going to be 30 over 2. Okay, let's make that blue. All right, I hope that's still visible. Into 2 times our a value is 3. Okay, so there's our a value there, plus, so that's n minus 1. Remember, n is 30, so that's going to be 29 multiplied by, in this case, we've got a minus 5 as our common difference. Okay, and we close that bracket. Okay, that's our blue bracket. So in this case, let's just quickly get that into the calculator. Okay, there's my calculator there, right? So, and we get a value of, so that's 15. And I seem to get a value of negative. Okay, so let me just go back to the white. So that's negative 2085. So the sum of the first 30 terms is 2085. Okay, I think that is that. Okay, so I want us to quickly jump into another one. All right, looking at our second example. So there we've got another expression that is given to us. So we are taking the sum there, and our counter this time does not start at 1, it starts at 2. And you should just be careful. Sometimes the counter starts at 0, and what that means is that you're going to add, just another. So if it's from 0 to 10, obviously that would be 11 terms, okay? Because you're not counting from 1, but you're counting from 0, okay? So in this case, we're counting from 2 till 10. Obviously, you would know it means that we would have 9 terms in this case, right? So let's start with term 1, term 2, and term 3. And for term 1, we've got 1 over 4 into 2 to 2 minus 1. So that's 2 minus 1. And then for term 2, that's 1 over 4 into 2. That's 2. Sorry, that's 3. Remember, we are incrementing now. Okay. And 1 over 4, that's 2 into 4 minus 1. And what I get there, so 1 over 4 times 2 minus 1, that's 2. Okay, that's 1. So 1 over 4 times 2, that would give me 1 over 2. So that's the first term, okay? And here I've got 1 over 4 times 2 to the power 3 minus 1. 3 minus 1 is 2. So that would be 2 squared, okay, which is 4. 4 times 1 over 4, that will give us 1, okay? And of course, the last one, that's 1 over 4 multiplied by 2 to the power 4 minus 1. 4 minus 1 is 3, and 2 to the power 3 is 8. So 8 times 1 over 4, that would give me 2. So those are the first 3 terms. And I realize this time this is not an arithmetic sequence, but look at this. Term 2, which is 1, divided by term 1. In this particular case, this is going to give us 2. But also term 3 divided by term 2 gives us 2. So we've got a common ratio, okay? Let's do that quickly. So we've got a common ratio there. And our common ratio is 2 in each case. Okay, so that simply means that if you take term 3 divided by term 2, you get 2. And you take term 2 divided by term 1, that gives you 2 as well. All right, so first of all, let's just see there. So it means our A value is 1 over 2. And it means our R value is 2. So in this particular case, because our R value is greater than 1, you remember that? So for the geometric series, you've got a convergent and a divergent series. And of course, it all depends on the value of R. So now we're looking for the sum. Now, please note, we are taking from 2 till 10. Okay, so how many terms is that? That will be 9 terms, right? So it means that we're going to say S9. Okay, so you remember the formula for the sum of your what do they call this? There's the name geometric series. The name just simply slipped out of my mind. Okay, so we're going to say this is A to the power, or rather, A bracket, we've got R to the power N minus 1, okay, divided by R minus 1. Of course, this is for when R is greater than 1. It would be expressed differently. And I'm not sure why I wrote A there instead of N. Okay, so that's Sn. So we know we're dealing with S9, right? Okay, so S9, that is going to be A. Our A value is 1 over 2. and I'm going to make those brackets to be different. Okay, so that's R. So our R value is 2. R value is 2. Okay, let me just use let me stick to white again. All right, yeah, having to toggle with these colors is a bit daunting, but we'll get there. Okay, so this is going to be 2 to the power. Now, please remember, in this case, we said n is 9. Okay, so 9 minus 1. Okay, and I'm going to close that bracket, divided by, in this particular case, divided by, again, this is going to be r, which is our 2 minus 1. All right, quickly, if we work that out, let's find out what that is. So this is going to be 1 over 2, okay, multiplied by 2 to the power 9 minus 1. Okay, all right, 2 minus 1 is 1. So that gives me a value of 255.5. So the sum, the first 9 terms, is going to be 255.5. All right, you can please verify that for me and just make sure that we are all on the same page. And essentially, that is how we would get our answer. All right, I hope that's been understandable. So just the last thing that I want us to do, I want us to take a series. What happens in a series when we are given, the series, and we want to express it as a sigma in sigma notation. Okay, let's look at that quickly. All right, so quickly let's look at this. They say express the following in sigma notation. Okay, my board got cut there. So that's 1 plus 5 plus 9 up until 21. All right, so the first thing that we're going to do is, let's find out first, what type of a sequence is it, okay, or rather a series it is, okay. So in this particular case, if I look at that, the first term, so that's going to be T1, that's T2, that's T3, and we don't know what T that is, but we'll get to that. So if I look at T2 minus T1, that's 5 minus 4 minus 1, which is equals to 4. So and that tells me that the difference between the first and the second term is 4. But if I look at term 3 minus term 2, again, that's 9 minus 5, which also gives me 4. So this kind of tells me that this is an arithmetic sequence. Okay, so now we're going to look for the sigma notation of it. But first of all, it means that our A value is 1 and our D is 4. Okay, so let's find the general expression. So that's what we'd always do. So find the general expression. So the general expression is Tn is equal to, now please remember, for the arithmetic sequence, that's A plus n minus 1 times D. Okay, so let's substitute for everything that we know. So Tn is A, which is 1, plus, in this case, n minus 1, n minus 1 multiplied by 4. Okay, so you've got 1. So we're going to substitute that in there. All right, and please remember, we're going to substitute into both of those. So now that becomes 4 times n, that becomes 4n, minus 4 times 1, and remember it's positive times a negative, that's going to be minus 4. So our general expression there is going to simply be 4n minus 3. So that is our general expression, right, for the sequence. Now, in this particular case, we know we're going to start at term 1. If you take that expression, let's see, if I substitute 1, okay, in there, that's 4 times 1 minus 3. That definitely gives me 1, which is the first term, okay. But now I want to know which term is 21. So let's find that out quickly. So which term actually gives us 21? So Tn, which is 4n minus 3, is equal to 21. So we're going to say this is 4n. I'm going to just take 3 to the other side. In this case, 21 minus, okay, in this case it would be plus 3. So that would give us 24. And if I divide both sides by 4, okay, so n would be equal to 6. Okay, so which means that the sixth term here, the sixth term is actually equal to 21. Yeah. So how do I write this as a sigma notation? All I'm simply going to say is, okay, please forgive me. I keep trying to write with different colors because I want it to kind of be visually appealing so that it just doesn't become bland and monotone. But of course, as I said, we'll get there. All right, so in this case, it's going to be n equals 1 up until 6. And our general expression, we said that's going to be 4n minus 3. Nothing wrong if you wanted to express it as k or whatever the other you have. In this case, remember, when you change it there, you also have to change it there. All right, and that is how you write that series in sigma notation. And by the way, I think that we want to leave this lesson here. Thank you so much for tuning into our channel again. And for those of you who haven't subscribed, you see, mathematics. So I wanted to say substitute. Those who haven't subscribed, please just make sure that you're part of the family. And I'll see you guys again next time. Sharp, sharp.